Okay, this time we're taking a look at Jun2007 Physics Paper 6 or A23. So this is question 4 from that 2007 paper. And we're looking at a neutral atom of beryllium, which has beryllium 94. State how many of each type of particle in neutral atom of beryllium. And basically we're trying to identify what are leptons, what are baryons again. So if we just consider here, we have beryllium 94. What that tells us is we have 4 protons inside the beryllium atom. We have 4 electrons because it's neutral, and we then finally have 5 neutrons. And when we consider those particles, proton, remember that's a baryon, electrons is, so that's a baryon, electrons are leptons, and neutrons again are baryons. Alright, so how many leptons do we have? Well, we've just said there we have 4 electrons, which are leptons, therefore we have 4. The explanation for that is because there are 4 electrons in the atom, and electrons are obviously leptons. The number of baryons then, well, again we had 4 protons which are baryons and 5 neutrons which are baryons. That gives us a total count of 9 baryons. And the explanation, that will be, well, we have 5 protons and 4 neutrons in the atom, and protons and neutrons are baryons. Are both baryons. Okay, so protons, neutrons, baryon, 5 protons, 4 neutrons, that gives us a total of 9. The number of mesons, well, if you go back up to our breaking down at the top, 4 protons, 4 electrons, 5 neutrons, baryons, leptons, baryons, no mesons at all. Okay, so the number of mesons there is going to be equal to 0, and that's because there are no mesons inside the atom. A reason for that could be that mesons have a very short lifetime, and so they're not going to be long enough around to exist in atoms. Alright. The equation that we're given here, x plus n goes to p plus e minus. So in this equation, lepton number is conserved, okay, and that's always conserved in the same way as charge is conserved. So if we take a look at that, x plus n to give p plus e, so x plus n, if that's plus, that's a proton, so that's plus, that's minus, so this side is neutral, that's neutral, therefore x must actually be neutral. So the sum of the lepton numbers on the left hand side must be equal to the sum of the lepton numbers on the right. By considering conservation of charge and conservation of lepton number, identify particle x. Right. So what I've done so far is, okay, and I'm just going to copy that equation down here so we can see it. So the equation is x plus n going to p plus e minus. So what I know so far is that the charge on the right hand side equals 0, so the charge on the left hand side must equal 0. Therefore x must be neutral. Okay. Then if we take a look at lepton number, right, well, this on this side here, this has got a lepton number of 1 because it's an electron. This has got a a lepton number of 0. This is a lepton number of 0. So that means that X must have a lepton number of 1. So X must be neutral and it must be a lepton. Alright, and the only neutral leptons that we know are neutrinos. Therefore it must be a neutrino. So X must be a neutrino in that particular one. So again, the charge on this side is 0, so the charge on this side must be 0, so that's neutral. Lepton number here, proton's a baryon, so it has 0 lepton number. Neutron's a baryon, so it's got 0 lepton number. This is a lepton number of 1, so the total on the right hand side is a lepton number of +1. That means that we must have on this side a lepton number of +1. Therefore we must have a neutrino coming through there. Okay, and that's the end of that particular question.